In this lesson, we are going to discuss exponential and logarithmic form of equations. So we're going to learn how to translate our problems back and forth between exponential form and logarithmic form. So the translation is below, so we'll have b to the x equals y, and then that is going to be what we call our exponential form, because we're using an exponent in here. And then this form, log base b y equals x, that is going to be your logarithmic form. So in this problem, when you look at number 8, and by the way, this is covered in section 10.5 of the book that we use on page 832 if you do want to see how they explain it. So they're going to ask you to write each expression in logarithmic form. So we're going to want to write it using this log here. So we always start by writing log, and we have our b, which is our base, and that's going to be right here, the base of our exponential form. So base of our exponential form is this 3 here, so we're going to put a 3 down here for our base. So this is called a subscript. A subscript is when you have a number that's down here just to the bottom just a little bit here. A superscript would be like an exponent, like how you would write this 5 here. So it's just a little bit below our log. Then notice that the difference between exponential form and logarithmic form is that they switched that x and y around. So what I'm going to do is when I'm in logarithmic form, I'm going to put whatever this equation was equal to next to my base, and then whatever my exponent was in exponential form is going to be what my log is equal to. So I'm going to, again, switch that 5 and that 243. So I get 243 here next to my base equals 5. So now let's try it again here. So I'm going to write my log base is 5. I'm going to switch these two guys, that 3 and that 125. So I have 125 here equals 3. So now, number 12, log base 10 of 1 equals 0, because I'm swapping these two guys around. Number 14, log base 3, and this is no different. Even though it's a fraction, you've got a negative exponent here, you still work it the same exact way. So I've got 1 over 81 here next to my base equals negative 4. All right, so now looking at number 16, we're going to take log base 3 and then 1 over 27 equals negative 3. 18, we have log base 125. 5 equals 1 over 3. Again, all we're doing is putting our log, this first number is our base, and then we switch these two here. So I've got log of 36 is our base, and then we have 1 over 6 equals negative 1/2. 22, log of 9 is our base, and then 27 equals 3 over 2. So now 24, log of 16 base, 1 over 64 equals negative 3 over 2. So now in this next page, when we flip over in our notes, the directions ask you to write each equation in exponential form. So we are essentially going backwards from the problems we just did. So it was b to the x equals y, and then translated, it was log, b is your base, and then you swap your y and your x. So to do this, my base is b, right here, so it would be 5. and then we're swapping these two guys back. So 1 is going to be the exponent of my base, and then my equation is equal to 5. So on 28, 3 is my base, and that's going to be my big number over here. And then my exponent would be the x, so my x is what my equation was equal to, so it would be 3. And then equals y, and my y was right here next to my base, which is 27. So when you're working through these problems, you should get a true statement. So if you're not getting a true statement, you did something wrong. So here we have 2 to the 5th power equals 32. 10 is my base. 10 to the 0 power equals 1. 5 is my base, so 5 to the negative 2 power equals 1 over 25. 10 is my base, so 10 to the negative 3 power equals 1 over 1,000. 38. 125 is my base, to the 1/3 equals 5. 9 to the 3 over 2 equals 27. And then 64 to the negative 2 over 3 equals, equals 1 over 16. All right, and that's how you translate equations back and forth between logarithmic form and exponential form. I hope this video was helpful, and I wish you the best of luck.